and also get the lecture.
Hey, Ben.
Hi, Ben. Good luck at state. I guess by the time you hear this, I hope you did well at state.
Good correction.
Okay, so our goal today is to use the first derivative test with word problems. And really, it could be the second derivative test. We're just finding extrema. But most commonly, the way to find extrema is the first derivative test. Doesn't have to be, it's just the most common. So, anytime we're working with a word problem, which is basically all the free response problems, so half the AP test, we need to be able to interpret what this word problem is asking us to do. So we need some kind of steps, a pattern to follow that can help guide us. It's not what we're going to do every time, it's just kind of some guidelines to help us through some of our word problems. So the first step, if it's any sort of geometric or graphing, is to draw a picture. You won't necessarily have to draw a picture with every question. But, especially if it's a geometric question, we need a picture. So then 2, writing an equation for what we want to find, that's probably the hardest step. Figuring out the equation itself that we're going to need, that's a pretty hard step. You have to make a lot of mental leaps and mental interpretations in order to write out the equation. So sometimes with our optimization, we will need more than one equation though. We can only optimize something that has 2 variables. The variable we want to optimize and what it's in terms of. So usually it's like over time or if area, maybe you want to optimize area and you just want x and not length times width. You can't have 3 different variables. We have to only be working with 2. So sometimes we need a second equation based off what is given, and we need this if the first equation has more than one variable. Because if it does, we've got to do some sort of substitution, step 4, so that we can replace and only have the one variable on the right side and then the main variable on the left that we're trying to optimize. So then last, once we've actually figured out our equation, then it's just straightforward calculus. Step 5, probably the easiest step as long as your brain has not been fried from figuring out the equation. Step 5 is just find the extrema using first derivative test, second derivative test, or very, very rarely the extreme value theorem. Sometimes we do have to consider a closed interval. But that honestly doesn't happen very often. So those are the basic, like I said, guidelines of what we're going to follow. But really the best way to interpret word problems and to get good at it is to practice, practice, practice some more. So we're going to do a couple of examples today together. Of our various different types of word problems that we could see. And again, the problem with this is on the AP test, you never know what type of word problem they're going to give you. And there's so many different types. We've got to be critical thinkers. We can't just memorize all the different types of situations you will see, because they're probably going to come up with a situation you haven't seen yet. For at least one, probably more than one of the problems. Good job, Lily. So you might be able to think through number 1 pretty logically, but I want to show how we could do this algebraically, show some of the interpretation. This is a very, very basic word problem. So find two numbers whose sum is 20 and whose product is as large as possible. So whenever I'm working with a word problem, I always identify what is it asking me to find. I need to know where I am going. So what is it asking me to do on this example? Find two numbers. Okay. Okay. So they want us to maximize something. They said as large as possible. What should we be maximizing? They want us to maximize the product. That's our goal. Maximize product. Now this one is not geometric in nature, so we can skip the drawing a picture. We can go straight to an equation. So first it says two numbers. How would we represent two numbers? We need some sort of mathematical representation for two numbers, and we don't know what they are. So they're asking us to find. How do we represent numbers that we don't know? X, a variable, and y. You can really pick any. So our two numbers are going to be x and y. And it said to maximize product. So what should our first equation be? What's our main equation if we're trying to maximize product? I'm going to use P for product. Could have named it whatever I wanted to, but I'll do P for product. So what should product equal? X times y. So we run into the problem of I have three variables. What I want to maximize and an x and a y. Somehow, I only want just x's or just y's. What I've got to get to. Only x's or only y's. We have to have product in there because that's what we're trying to maximize. We can't get rid of that. So we need a second equation. What other information could give us a second equation? The sum, so x plus y equals 20. Since they actually gave me the sum, then I don't want to use a variable, which I just wrote. Did the opposite of what I was trying to say. I want to put in the number. So x plus y equals 20. And we want to somehow use that equation to either get only x's or only y's in this first equation. Think back to algebra, systems of equations. It is useful. Okay. Okay, so we need to substitute, but we have to solve first. So Evelyn very quietly whispered.
X equals 20 minus y.
We solve for x. Or I could have solved for y. I could have said y equals 20 minus x. Doesn't matter. Then I can substitute it into my main equation. So I get 20 minus y times y. So we've gone through the harder part. We've interpreted the question. We've come up with an equation. We've done our substitution. Once we've done that, now we're to the easy basic steps of calculus. How do I maximize something? How do I find if it has a maximum at all? Derivative. Line test. Set the derivative equal to 0. Find the critical points. Perform a line test. So I would recommend you could do product rule, or I would recommend distributing this in, simplifying it first. But I'm going to have you guys finish this problem. So we've done the setup, now finish. So again, this one was pretty straightforward. Everyone I checked got it correct. We distributed out. I did. Think I did. I did. The red light is blinking. We take the derivative, we get p prime. Set it equal to 0, we get y equals 10. Okay, so what I didn't see a lot of people do though was a line test. And I just realized that.
It's a maximum.
You did do your line test?
Do my
Yeah.
license.
So, yes, this is our only answer, so most likely it is what we're looking for. But we need to provide proof. So, we need to practice making sure we take that extra step and provide proof. Even though this one it's pretty straightforward and we know this is going to be the maximum. We should perform a line test. 10. So if I plug in, I'm going to do 0 just because it's easy to plug in. We get positive. If I plug in 11, we get negative. So yes, y is at our maximum. And then once we've found and proved that y is a max, we can also find x. It did say to find both numbers. So if I go back to my substitution piece and plug in y, that'll give me x. So still, again, make sure you perform your line test, even though a lot of these it's only going to give you one answer, so we're like, hey, this has to be it. But we need to practice providing the proof, because usually on the AP test it will not be that clear. You'll have to do the proof in order to know whether it is a max or a min. So what I've found surprising in the past is most calculus students actually struggle with a lot of the geometry we have to do in here. It's been so long since you've done a lot of geometry, and the geometry is a lot more advanced a lot of the time than you did when you were, a freshman or sophomore or whenever you had geometry. And this one is coordinate geometry. We're going to be putting shapes on the coordinate plane. So we have a rectangle to be inscribed under one arch. Arc or arch?
That's our.
Arch.
I think it's arch. Arch.
Oh well.
Just
One piece of the sine curve will replace. What is the largest area the rectangle can have, and what are the dimensions? So again, we need to figure out what are we trying to maximize first. We want to know what are we trying to maximize. So what is our goal? What are we trying to get the maximum of? Area. We're trying to maximize area. Area of what? Maximum.
Rectangle.
Are you sure?
The rectangle. The reason I stress finding this kind of goal is because it can help us identify what equation we would need to use. So what equation are we going to have to work with if we're trying to maximize area of a rectangle? Even just ignoring the rest of the problem, what equation would we need to use?
Length
Length
times width.
times width. We know at some point we need to involve length times width. That's going to be involved somehow because we need A prime. Again, we run into the problem of having an L and a W, which I can't use. So now we need to, in this case, draw a picture. We're using a rectangle, geometric shape, so we definitely need a picture. And we have our coordinate plane. So it's at the first piece of the sine curve. So where does sine start?
0.
0. When do we hit 1 on the sine curve?
I have.
Pi halves. And then back to 0 at pi. So we're looking at this piece of the sine curve. They said just one arch or arc or piece. So just that piece. And we're trying to inscribe a rectangle. Now this rectangle could look a lot of different ways. I could have maybe a smaller rectangle that's inscribed, or I could have one that's hitting the top so it looks a little taller. So it could look a lot of ways. Usually when I draw the picture, I just kind of pick a medium-sized one, just for picture purposes. So let's pick this one just for picture purposes. But keep in mind, this is not the only picture we could have. There's a lot of different ways our rectangle could look. So again, we're going to have to do some critical thinking. And they involved sine for some reason. We need to figure out how sine is going to work with this. So if I'm looking at this, we have the corners of our rectangle. If I can identify the corners of my rectangle, I can find the length and the width through subtraction. So, if I go from the origin to here, what do we usually call that value? We don't know the exact value, so again, it's a number we don't know. So it's x. Again, specifically, this is on the x-axis, so this time I want to use x without, and not just pick a random variable. So I found that value. What about this value here? If I wanted to get up to here, this would be y. What else? Let's use x, though, to represent this. What else can we write y as when we have a function? That's right, heard someone say it. F of x. Another way to write y is f of x. But that keeps our x involved in this process. F of x. So right now, we know two distances. We know the distance. I'm going to pick a different color so we can. Okay, we know the distance from here to here. Oh, it didn't go pink. Oh well. We'll use marker instead. The distance from here to here is x. And we know the distance from here to here is y. One of those distances matches the distance on my rectangle. Which one already matches my rectangle? The f of x. Okay. But this x gives me a distance that isn't on my rectangle. We need some more information to find this area. So let's call this width. We know width is f of x right now. We still don't know length because the distance of x only gives us from the origin to the rectangle, not the actual distance of the rectangle. But we do know something about a sine curve. A sine curve is symmetric, and a rectangle is symmetric. So if I cut this in half, each side would be the same. So what could we label on the other side?
X.
X.
Which I already said 2x.
This is also x. Okay. So I have an x here, I have an x here, and I know the entire distance from here to here. What's the entire distance? Pi. So if I know the entire distance of something, and I know pieces of that distance that I don't want those x's. How can we get rid of them geometrically? Subtraction. Geometry is often about subtraction. If I know the entire distance and I want to get rid of some pieces on that distance, or if I know an entire area and I want to get rid of a few pieces in that area, we need to subtract. So we know the entire distance was pi, and we want to get rid of those pieces we don't want. So we want to get rid of the x's. There's 2 of them, so we minus 2x. We could have also said minus x, and then simplified, but we say minus 2x just to save us some time. So now we know a width and we know a length. We can go to our area function and replace. We know length is pi minus 2x. What did we say width was? F of x. So we're getting closer, but now we have a whole bunch of x's, an a, and an f. That still gives us some trouble. What do we know about f of x? They gave us a function. What function is f of x? Sine. They told us it was put on the sine curve. So I can replace f of x, this entire thing, with sine x. So again, most of the critical thinking on these problems come with setting up the equation. That's the hard part, is setting up the equation. You can take the derivative of this pretty easily. Now it does involve trig, so when we set it equal to 0, that might cause you some trouble. But if it didn't involve trig, setting it equal to 0 wouldn't be a problem either. So this one let's do together so we can see what happens when we set it equal to 0. So this time, how am I going to have to find the derivative of this? Product rule. Okay. Even if I distribute sine in, I'm still going to have to do product rule. So I might as well leave it as it is for now and do product rule. So low d high, sine is low, times the derivative of the first. So times -2 plus high d low, high minus 2x times cosine x. So now we should do a little bit of simplifying. We have -2 sine x plus pi cosine x. I'm actually going to leave it in fact form. We have to set this equal to 0. So I'm trying to think of a way we could even solve this algebraically. We may have to resort to calculator.
Class is called calculus for a reason.
I had looked up the problem before when I typed it up, but now I'm forgetting. I swear there's a way to do it algebraically. So let me see if I...
Oh, I'm sure there is.
Darn it. Just finished it too.
Really? Huh. It is not possible to solve this equation using algebraic methods.
Wow.
The book confirmed. So, this one we just need to plug it into a calculator.
Okay. It's -42.4342.
Are you in radians or degrees?
Should be in radians. Let me check real quick.
I feel like -42 sounds
Well, this is
Very-
just one of the ones maybe a sophomore changed. It's possible. Hold on just a second.
I have that too.
You got negative 42 as
Yeah.
well? That's yours?
Yes.
So it's already in radians? Okay. So negative 42 point,
4342.
what about a fifth decimal?
That's it.
That's all I gave.
4.4342?
Yeah.
I feel like they should have been in
And
the
it
fifth
says
number.
that more functions figures exist, they like keep listing. So do you want?
Mine just said or and gave me like 4 more equations.
Yeah. So with trig, you know, you can have the coterminal angles, so you can have an infinite number of solutions.
So which ones do we use?
Okay, the reason I would say we would not use this is let's go look at our picture.
Oh, it's a negative.
X can't be negative. That is impossible.
There's 4.99641. Sounds a little more realistic.
4.996. So you're saying 4.9971, and Melinda, you said
I said there's a 0.710463.
so between these two, we should decide which one makes more sense. So again, let's go look at our picture and see what should we know about x. What does x have to be smaller than? Pi. And what do we know pi is? 3.14159.
Oh.
So, which one would have to be our answer?
The 0.71.
The 0.71. The only one that's not negative, that's less than pi. So 0.71, 0463 is x. I need to go back to the question, sorry, to make sure we're answering everything. What is the largest area? Okay. And what are the dimensions? So that's not even one of the dimensions. Okay. That's just the piece on the graph that we had to get rid of. So that's not even one of the dimensions, and we still should check that it's a maximum. Yes, we can probably assume it's a maximum because that's the question we're working with, but so let's pick 0.5, so 1/2, and we have to be less than pi, so 3. So if I plug in 1/2 into the derivative, again, we just have to have a calculator. It should end up being positive since we're trying to maximize. So Evelyn, are you trying to plug in 1/2? Okay, Evelyn's going to plug in 1/2. Eliana, will you plug in 3 into the derivative? Just to, again, make sure we need proof that this is actually a maximum. We're pretty confident because it's the only one that makes any logical sense, but we need some proof. Yes, we wanted it to be positive. I was like, I swear that was supposed to be a negative, but no, we wanted it to be positive. So good, we got positive, got negative. Okay, so we've proved it's a maximum, and now we just find the dimensions. We had equations for the dimensions. What was our equation for length? Pi minus 2x. So we have to do pi minus 2 times 0.710463. That's why I used so many decimals because I knew we'd have to plug it back in. We need width, sine of x, so sine of 0.710463. So Emma, are you finding length? And Josh, will you find width?
0.65218.
Oh, was that length or width? Is that the
That's
sine?
the sign.
Okay, that's 62185.
Yeah.
I got 1.72067.
So we have our length and our width now. And then what was the last thing we have to find? Area. Because they told us to find the area. So we go, area is 1.72067 times 0.652185. Whatever that happens to be.
1.12219.
1.122. And then they didn't give us any specific units, so we would use units squared, just to show that this is an area. So I have just one more example and then we'll get started on the assignment. I did want a little more time today so you could work with each other since they're word problems.
Could we finish it in class? Is that a possibility?
I'm gonna go with no.
Oh, it's down.
It's, wait, not.
That's cute.
Like, it is best things
You have been asked to design a 1 liter oil can shaped like a right circular cylinder.
But was there like oh,
What dimensions use the least material? So we're working with a cylinder and we're trying to use the least material. So what is our ultimate goal with this one? What are we trying to maximize or minimize? Trying to minimize. What are we trying to minimize?
The amount of material.
The amount of material used. What do we call that geometrically?
Surface area.
Surface area. We're trying to minimize surface area. Which means I need to be able to find surface area of a right circular cylinder. You probably do not have the surface area memorized. I don't. I just figure it out every time. So let's draw a picture again. So we need a surface area equation. How do we find surface area? Just in general. If I had a cube, how would I find the surface area of a cube? It's kind of like perimeter for one-dimensional or two-dimensional shapes. How do we find perimeter?
You add up all the sides.
Add up all the sides.
You add up the area of all the sides.
Add up the area of all of the shapes that make up the entire shape of the cylinder. So first we need the area of this top shape. What top shape do we have? Circle. So pi r squared.
Will there be two though? Because there's
Okay.
no.
Josh made the point I was going to go to next. Since there's one on the bottom, 2 pi r squared.
and then plus circumference times height.
Good. We think of a cylinder as a flat sheet of paper rolled around. So area of the rectangle that actually makes up this outer piece is the circumference of the circle times the height, so 2 pi r times h. I don't know why I put colons, it should be equals. We're writing an equation. So what's wrong with this equation? Why can't I just go minimize it right now?
Two variables,
Okay, what two variables?
R and H.
R and H. Somehow I need to get rid of R, or I need to get rid of H. So we need to go back to the question and see, is there any other information given that can help us come up with a second equation? So what other information did they give us that might help?
The area is
So
1
here,
liter.
so it's a set volume.
Okay, it's a set volume. They gave us this 1 liter oil can. So does anyone know what the volume of a 1 liter oil can is?
1 liter.
It's 1,000, I think, centimeters cubed? Maybe.
I had it in my chemistry notebook, but I took it out of my bag.
And that's something you wouldn't have to have memorized. They would probably be a little more specific. But we know the volume is 1,000 something cubed,
I
not
think it's-
100%.
I think it's milliliters.
Milliliters cubed. Okay.
What?
Okay. So volume of 1 liter.
Is Google
I don't
allowed in
remember
the
all
AP
these small
test?
things. Do you know all the stuff you have to remember? Organic chemistry is a whole different world, you guys.
Yeah. So while she's Googling, we still need an equation. What is volume of a right circular cylinder?
R squared times H.
Pi r squared times h. Anytime we have a cylinder or a prism, you take the base shape and multiply by the length or the height. It's like we stacked a whole bunch of circles up, or if you stack a whole bunch of rectangles up, you get a prism. So pi r squared h. That is something you should memorize. You should memorize volume of a cylinder. Surface area, you should be able to figure out. Volume of something like a right circular cylinder should be memorized. So we know the volume is 1,000 something.
It's 1,000 cubic centimeters.
I was right.
She was right.
How it is that, I don't know, but hooray, I remember. Last year I screwed up gravity like 5 times, and so now I celebrate any victory. I'm like, I remembered right, didn't screw it up. So what should we do to then
Solve for H.
solve for h? I would probably solve for h. Solving for r, we'd have to plug it in twice. So 1,000 over pi r squared. Also, if we had solved for r instead, we'd end up with a square root, which might make our life a little bit more difficult. So we can do some canceling. Pi will cancel. 1r will cancel. 2 times 1,000 will make 2,000. So just cleaning this up a little bit. So calculus-wise, I should also clean this up one other way to make it easier to take the derivative. What can I do to rewrite or rearrange things so that it's easier to take the derivative? R to the -1, otherwise you have to do quotient rule, which you could do, but so now we are ready to take the derivative. Surface area prime is, I could also have called this dSA over dr, derivative of surface area with respect to the radius. their own civil Leibniz notation. We'll be using that a lot when we get to related rates. So 4 pi r minus 2,000 r to the negative 2. Now we have to set this entire thing equal to 0. So if we have r to the negative 2, what's a spot that will give us trouble because it doesn't exist? 0. If we're really over r squared, 0 would give us trouble. But since we're doing an application problem again, could we have a radius of 0? No. So we ignore 0. Once we do application problems, we have to think about the logic behind it and what could we use and not use. So we have, I'm going to add this over. 4 pi r equals 2,000 over r squared. We already considered 0 and threw it out. So now if I multiply by r squared, it's not going to cause me any trouble to do that. Otherwise, you might get extraneous solutions when you do stuff like that. But we already considered one of the answers. And threw it up. So we divide by 4 pi, cube root. So whatever the cube root of 2,000 divided by 4 pi is. And for that, we need a calculator.
Everyone's got this.
It's 505. Oh, I didn't do that part.
Okay, I was gonna say, I think it'll be a weird decimal, because square root of pi is something odd. Did you find it, Stephanie?
It's 5.41926.
3 decimals. Is that what you got as well? Or did you give it?
2.6.
2 6. Not
I
6.
don't even want to talk
Sorry.
to us. Look.
Just to save some time, let's not do the line test just because we know it's going to work. But on the homework, I do want you to do the line test just so you can get started on your homework. So that was the radius. What dimensions? So what else do we need? Height. So this time it didn't ask us for surface area as part of our answer. It just asked for height. So height was...
It was 1,000 over pi r squared.
1,000 over pi times 5.41926 squared. Whatever that gives us. Make sure when you plug it in, you plug, wait, we have the fancy calculator, so we don't have to worry about that. Never mind.
We got 10.8385.
10.83. So now we found the height and the radius. So you have about half an hour. To do problems 1 through 5, 7, 9, and 13.